All right, so 8.4 is binomial theorem. What you're going to learn in this section is how to expand binomials using a different pattern than just like foiling them out. It's basically the idea behind it. So when you multiply binomials, first of all, what's a binomial? Two terms. Okay. What does it mean to expand something? Distribute. Both of you are right. Okay, so if it said to the fifth power, that's technically x plus 5 times x plus 5 times x plus 5 times x plus 5, I lost count, times x plus 5, right? Yeah. And then you would FOIL it out, okay, before today. So today we're going to learn a different method of doing it. So from this slide, try to give you a visual. There's a couple of things you should notice about what happens. So this was already expanded, like terms combine in order, decreasing degree, that kind of thing. In each expansion, there's n plus 1 terms. So the n comes from the exponent on what you are multiplying. So if something's raised to the fifth power, there is 1, 2, 3, 4, 5, 6 terms. If something's raised to the sixth power, there's 1, 2, 3, 4, 5, 6, 7 terms. So right off the bat, you should be able to figure out how many terms they're on based on the exponent of what you are multiplying. So it's always that plus 1. The second thing you should notice is that x and y, which are going to be like your first term and your second term, have symmetrical roles. As one decreases, the other one increases, and they mirror each other. So if I were to look at x to the fifth, the last one's y to the fifth. This is x to the fourth, y to the first. This is x to the first, y to the fourth. This is x to the third, y to the second, and this is x to the second, y to the third. So they mirror each other. As one is decreasing, the other is increasing in the same increment. Same thing is true for here. This is 6 and 6. This would be 5 and 1 and 1 and 5, 4 and 2 and 2 and 4. And then this one in the middle, where it doesn't have a match, they should be equal. The last thing in the purple there, it says the sum of the powers of each term is n. So if I were to take each of the terms in the first one and add the exponents, this is obviously 5. This is 4. What's the exponent on that y? A 1, that's 5. 3 and 2 is 5. 2 and 3 is 5. This would be a 1. 1 and 4 is 5. And the last one is 5. So each individual term, the exponents would add up to whatever it is you're raising the initial function to a power of. Dominic.
Where did they get the leading coefficients from?
I'm going to tell you where you get it from. So that's going to be like this kind of is divided into a couple of parts. One is what to do with the exponents, what to do with those terms, how to find the leading coefficients. I'm going to teach you 2 ways to find them. So for right now, you're just kind of looking at the pattern, because when you get an answer, you should be able to look and say, do I have n plus 1 terms? Are they symmetric? Is it, do each exponent, do they add up, that kind of stuff. The second to last thing down here says the coefficients increase and decrease in a symmetric pattern. So we just talked about that. If I start at 5, it goes 5, then 4, then 3, then 2, then 1, then 0. And then on the other exponent, it would be 0, then 1, then 2, then 3, then 4, then 5. And then this, just vocab terminology. The coefficients of a binomial expansion are called binomial coefficients. What are coefficients?
Numbers.
The numbers in the front, right? Yeah.
So for the pattern, you said like it'll either be decreasing and then increasing like that.
Correct.
Will it always be the first variable that is decreasing and then the second variable that is increasing that way?
Yes.
Okay.
And honestly, it doesn't, you could switch it, it's still the same thing. But yes, that's how we will
Okay.
model our pattern. Yep. Whatever is in this first spot would be your decreasing. Whatever's in the second spot would be your increasing. And it starts at 0. So when we say decreasing, we go from that number down to 0. And when we say increasing, we're starting at 0 and working our way up to n. Okay? Back here, this is C50. This is C51, 52, 53, 54, 55.
Okay.
Does that make sense?
Yep.
Okay. So this is what the binomial theorem basically says, that in the expansion of x plus y to the nth power, everything we just talked about, that it would start at n and then work its way down, and then the other way around works its way up. But this is what's new. So this is one way to find the coefficients of your terms. The CNR. The n is the number that is your exponent. on your original binomial. So the n is there. The equation is n factorial over n minus r factorial times r factorial. The r is which term you're trying to find. So the very first one would be c, and let's say that this is raised, let's just say it's to the third power. It would be 3, 0. And then the next one would be c, 3, 1. And then the next one would be c, 3, 2. And then the next one would be c, 3, 3. So if it's something raised to the third power, I know it has 4 terms. And the very first coefficient, God bless you, would be the 3, 0. The next one would be the 3, 1. The next one, 3, 2. And the last one, 3, 3. And then for each one of these, you would use this equation to find the coefficient. So there's 2 parts to building your your expansion. One is the variables themselves raised to a power. The other is the coefficient that goes on the front of them.
Hey, which one is R?
R is the location, like which term are you on? The first one is 0, and then 1, and then 2, and then 3 as you move to the left to right. So if I go, the other thing is this little notation is the same as that notation. So if I wanted to find C, N being 3, R being 0, I can also write it as 3, 0. N in the top, R on the bottom. So those mean the same things. So the number N goes at the top, R goes at the bottom. And obviously this is why we're following these last couple of sections, because we just talked about factorials, right? All right, so first example, find the binomial coefficient. So again, it is CNR equals n factorial over n minus r factorial times r factorial. So A would be 9 factorial over 9 minus 7 factorial times 2 factorial. Oh, sorry, I did it in my head. Yeah. This is 2. Brain's working faster than my hand. So this would be 9 factorial over 7 factorial, 2 factorial. And then break it down. So 9 times 8 times 7 factorial over 7 factorial, 2 times 1. Then simplify. So the 7 factorials cancel out. 2 goes into 8 4 times. And I end up with 9 times 4, which is 36. You try B.
Wait, how did you find R?
It's R is the one on the right.
Oh, okay.
Yeah. Okay, so on the, what do I have? The plus CE, if you go into math and you go over to probability, there's that NCR. If I hit enter there, on the left goes my N, which in this case was, what was it? 11, right? 11. On the right goes my R, which in this case was, what was that number? I'm covering it. 4. And then I hit enter, and there's my 330. For the other model, like the one that didn't have the color, you have to first do the 11, then go to your math menu, go over to probability. You still have an NCR. It just doesn't give you the subscripts, right? Mm-hmm. And then do the one after it, 4. And then hit enter. It still gives you the 330.
Okay, wait. I did.
So if I do 8 factorial over 8 minus 0 factorial times 0 factorial, I get 8 factorial over 8 factorial, 0 factorial. These get canceled out. And I get 1 over 0 factorial, which is 1. So don't forget that because there's no other way to figure that out, okay? I think a calculator would spit it back out for you, but without that, you'd need to know 0 factorial is just 1. All right, so we're going to actually use this to expand the binomial. When you write out the coefficients for a binomial that's raised to power, you're expanding it. We talked about what it meant to expand. To expand, we're going to write out all the variables in decreasing degree order for the first term and increasing for the second. So it's the first thing we do. Take whatever the first term is, decrease the decrease the exponent, take the second term, increase the exponent, and then find the coefficients using what we just did, and then multiply each term out until you've got your full expanded binomial. So we start easy, okay? Honestly, if this was a test or a quiz or standardized that just said expand, it is probably not that difficult just to do x minus 2 times x minus 2 times x minus 2. But when you get to like x minus 2 to the 10th or x minus 2 to the 7th, it's probably easier to do it with the expansion. If it says use the binomial theorem to find the expansion, then I'm expecting to see it this way. So the first thing I'm going to do is identify how many terms are there. How many terms should my answer have? 4. Always one more than your exponent. So 1, 2, 3, 4. 4 terms. Then I'm going to take the first term, which is x, and raise it to the highest exponent, which is 3. So x to the third, then x to the second, then x to the first, then x to the 0. So I decrease it, starting with n and working my way down. And then I take the second term, which is a negative 2, so the negative stays with it. And I do the opposite, increasing from 0. So negative 2 to the 0, negative 2 to the first, negative 2 to the second, and negative 2 to the third. So I took the first term and raised it to n, worked its way down. Took the second term and did the reverse. Started at 0 and worked my way up to n. So I can already start to simplify it. I could say that this would be negative 2 to the 0 is what? 1, so this is just x to the third. Negative 2 to the first times x squared is a negative 2x squared. Negative 2 squared is 4 times x to the first is 4x. Negative 2 to the third is negative 8. X to the 0 is 1, so this is just negative 8. With me so far? Now I need my coefficients. So if you need to leave the space, you can. It doesn't matter as long as you realize you still are not done. You still have to find the binomial coefficients. So I'm finding C, 4, 0, C, nope, sorry, not 4, 3. 3, 0, C, 3, 1, C, 3, 2, and C, 3, 3. So now I got to do my little formula for each one, right? This would be 3 factorial over 3 minus 0 factorial times 0 factorial. Christian, what did we say this was going to be? 1. Well, this is 1. So that goes here. Then I go to 3, 1. This is 3 minus 1, 1. 3 factorial, 2 factorial, 1 factorial, 3 times 2 factorial. And those cancel. And I have just 3. And then I go to the next one. 3 factorial over 3 minus 2 factorial times 2 factorial. 3, 2, 1, 2 factorial. This is 3.
Wait, so how do you know which one like correlates with which?
It goes in order. First one would be 0, then 1, then 2, then 3.
So like the zeros for the x to the third.
Yeah, and you could actually totally switch those. It doesn't matter because it's symmetric. So you could start at 3, then 2, then 1, then 0. You'd still get the same answer. So now this is 3. 3 minus 3. 3. And again, we said that's 1.
How do you get C3, 3?
Like, how did I know to do it, or how did I actually work it out?
How did you get the numbers 3 and 3?
I know n never changes. N is always the exponent on the binomial, which in this case is 3. That's always the one on the left. And then on the one on the right, you're doing 0, then 1, then 2, then 3, then 4, then 5, until you hit n. So in this case, n is 3. So I do 0, then 1, then 2, then 3. So if my n was 7, I'd be doing 7, 0, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, and 7, 7 until they equal each other. All right, with me so far on how to find the coefficients? So now I have to multiply this whole row out. No, you do it until you get to n. So 3 and 3. That's the highest you do it. You're doing it until the right side hits the left.
So the number that you put on the C thing,
Yep.
it's not the exponents that are on
No.
those terms.
I mean, it technically is the exponent on the second term.
Okay, it's not.
So now I'm going to multiply this out. So 1 times x to the third is x to the third. I'm going to multiply this one out. 3 times negative 2x squared is negative 6x squared. Multiply this out. 3 times 4x is 12x, and that's positive, so it gets a plus. And 1 times negative 8 is negative 8. And there's my expansion. And we can check something like this pretty easily, right? We could do x minus 2 times x minus 2 times x minus 2. So if I did these two first, I'd get x squared minus 4x plus 4. And then multiply it times x minus 2.
That's only if this was like a low number.
You can always do it. It just would take a lot longer if it was a higher number. And I get x to the third minus 6x squared plus 12x minus 8. What's the very first thing you need to do from this?
Right 5 rows.
Say again. Figure out that there's 5, right? So n is 4, which means that there's 5 terms. 1, 2, 3, 4, 5 terms. Then go through and do your exponents. Now, this is what I was talking about before. It's not always 1 for the very beginning, because what if your term has a number on it? So that is going to be 2x raised to the 4th and negative y to the 0. And then the next one is 2x raised to the 3rd, negative y to the 1st. And then the next one is 2x raised to the 2nd, negative y to the 2nd, 2x raised to the 1st, negative y to the 3rd, 2x raised to the 0, negative y to the 4th. With me so far? So then 2x to the 4th is 2 to the 4th, x to the 4th. So this is 16x to the 4th. Negative y to the 0 is 1. 2x to the 3rd is 8x to the 3rd times negative y. So this is negative 8x to the 3rd y. 2x to the 2nd is 4x to the 2nd. Negative y squared is y squared. 2x to the 1st is 2x. Negative y to the 3rd, negative y to the 3rd. So this is negative 2xy to the 3rd. And 2x to the 0 is 1. Negative y to the 4th is y to the 4th. So I'm going to leave a space for the coefficient, but I can already fill in part of this. Now n is 4, so I'm doing 4C0, 4C1, 4C2, 4C3, and 4C4. What's the first and the last one? 1. So eventually, the more you do this, the coefficients never change. If it's 4 terms, it's always the same 4. But we'll practice it a couple more times, and then I'm going to show you something else.
Pass the triangle, please.
Yes.
Yes. At the end, do it 5 times.
Accordingly.
If we know it mirrors, do we have to?
Mm-mm. So the question is, if you know it's symmetric, do I have to continue to do it? No, just be really careful. Especially if it's a quiz or a test, that could be your way to check to make sure you were right the first time. But in a minute, I'm going to show you Pascal's triangle, so that's another way to kind of memorize it too. All right, so now I plug in my coefficients. So the 4, 0, 1, which is our first one, was 1. Second one was 4. Third one was 6. Fourth one is 4. And last one is 1. And then I just multiply out what's left. So 16x to the 4th. A positive 4 times a negative 8x to the 3rd y becomes a negative 32x to the 3rd y. Positive 6 times positive 4 is positive 24 x to the 2nd, y to the 2nd. Negative 8x, y to the 3rd, plus y to the 4th. All right, so in this case, it's looking for just one specific term. So you're not multiplying out the entire thing. This is where it saves a heck of a lot of time to do something like this than it would be that here is something raised to the 10th power, find the 5th term, and you spend the time multiplying something out 10 times instead of just finding one specific term. So if I wanted to find one term, let's say I want to find the 3rd term, okay? Because that 3rd term is really because if you think about it, it's 0, then 1, then 2. That 3rd term is really an exponent of 2, which is where this comes from, r plus 1. So if I'm looking for the 3rd term, your r is 2. If I was looking for the 6th term, your r is 5. So when you're finding your coefficient here, this is always 1 less than the term you're looking for. So if I'm looking for the 11th term, what is my r? 10. Does that make sense? It's always 1 less. The n is always still the exponent that's on your expanded, or on your initial question. So if I wanted to find the 3rd term of this, then I would find the coefficient. So this is the 3rd term, meaning that r would be 2. This is my exponent, which would be 3. My r would be 2. And then I'm finding the x, which is this one, of the n minus r, which would be the 1st power, and the y, which is this term, to the r, which is 2. So from this, if you could memorize this, it'll make your life so much easier. The first thing you have to know is r is always 1 less than the term you're on. And then to find your coefficient, you would do the n and the r. The x, which is really just your 1st term, so don't let the x confuse you. This is really n, our 1st term to the n minus r, and 2nd term to the r. That's really what it is. Katie?
It's like n is the exponent?
Correct.
Or the term that it's asking for?
N is the exponent. The term gets you to r, but it's not even r. So the term is r plus 1. So you would subtract 1 from it to get to the r.
So the exponent for where the x is will always be 1 if it's n minus r. Because if r is 1 less than n.
If it's n, no. R is 1 less than the term. So if my whatever's in here is raised to the 11th, let's just say, and I want to find the 7th term.
Oh, okay, so then r would be 6.
R is 6, exactly.
Oh, okay.
Right? And then I would do C, N, R. And then I would do x, which in this case is x, to the n minus r, which would be 5. And then the second term, which in this case is y, to the r, which is 6.
Oh, okay.
Does that make sense?
Mhm.
Okay. So example 4, find the fifth term of a plus 2b to the eighth. So from there, we can identify n is what? 8. And if it's what is the fifth term?
Going to be 4.
Good. So I'm doing C8, 4. The first term, which is a, what's my exponent? N minus r, which is 4. Second term, which is 2b, and what's my exponent? 4, because it's r. So now C8, 4 is 8 factorial over 4 factorial times 4 factorial, 8, 7, 6, 5, 4 factorial. These cancel. 4 goes into 8 2 times. And then 2 and 2 cancel out. 3 goes into 6 2 times. And I have 7 times 2 times 5, which is 70. And then 2 times 2 times 2, 16. B to the fourth.
Where'd you get the 16?
2 to the fourth. So 2 to the fourth, b to the fourth. Sixth term of a plus 2b to the eighth. What is n? N is 8. If it's the sixth term, what is r? 5. So I am doing C8, 5. A, and the exponent on the first one is what? N minus r, right? So 8 minus 5, which is 3. And the second one, which is 2b, is r, which is 5.
Wait, what did you just do for the a and the third? You did the formula? The c and n, or the n?
So the first term gets the n minus r. The second term gets the r. Because think about what's happening here. This still has to add up to 8. One is decreasing till it hits the sixth term, and one is increasing till it hits the sixth term. So now I'm going to do C8. Oops, a daisy. How is a to the raised to the third power? Because that exponent is n minus r. So this is 8 factorial over, and I'm going to use the calculator because we're running out of time. 8, 5 is 56. So 56 times a to the third, 2 times 2 times 2 times 2 times 2, which is 32 times b to the fifth. And then 56 times 32 is 1,792, a to the third, b to the fifth.